Good afternoon, everyone. So yesterday, in the previous lesson, we talked about how to simplify, multiply, and divide rational expressions. And we also took a look at the domain. What we're going to be doing today is we're going to be adding and subtracting the rational expressions. But in order for me to go through that with you guys, we actually have to kind of take it back a little and talk about this least common multiple, or the least common denominator. Now, I am going to start channeling your 5th grade teacher again. Now, when I am taking a look at the numbers 27 and 18, and if I ask you guys to find the least common multiple, most of you will have different strategies to do this. Some of you will just keep multiplying 27 by 2, by 3, by 4, and then do the same thing with 18. But when you first learn to find the least common multiple, I'm fairly confident that you guys learned it with the prime factorizations of each of these numbers. So when I'm taking a look at the prime factorization of 27, I know that that's going to be 3 times 3 times 3. And then I know that 18 is 2 times 3 times 3. Now, when looking for the least common multiple, what you would have been asked to find then is, well, what do they have in common? What factors are they sharing? So I can see when I take a look at this that they're sharing this 3, and then they're also sharing this 3. So each of these factors goes into your least common multiple, but because they are shared, they only go in one time. So this 3 was that one, and this 3 was that one. Well, then we have to look and say, hey, what's left over? Well, I can see that I have a 3 left over. Well, that 3 has to go in one time. And then I have this 2 left over, and so that has to go in one time. And so what I end up getting then when I'm taking a look at this is I end up getting a least common multiple of 54, which I'm sure you guys would have gotten had you done the exact same thing, or listed them, or used your awesome mental math skills. But what's going to end up happening, though, is you guys are going to end up looking at problems in which you don't have just integers, you actually have some polynomials. Now, in a question like number 3, if I was asking you to find the least common multiple, I do not expect you to do what I'm about to do every single time you do one of these. I'm just showing it to you to show you how it works. So if I was to take a look at the prime factorization of this, I have 2 times 2 times 3 times x times y. And then I have 2 times 3 times 3 times x times y times y times y. Now, I'm going to go through the same process I just did when I was dealing with 27 and 18. Now, the first thing you guys want to say to yourselves is, okay, well, what do they have in common? What factors are shared? So the first question you're asking yourself, what factors do I have that are shared? So I'm going to circle the shared factors. So those are all the factors that they have in common. So when I go to write my least common multiple for these, I'm going to write each of those shared factors one time. Well, now what I need to do is I need to look and say, okay, well, what's left over? So when I'm looking for the ones that are left over, well, 2 is left over, 3 is left over, x is left over, and both of those y's are left over. So what I have here is I have my, what I call the leftovers. Sorry, it's not food. And then I also have the shared factors, what they had in common. So I'm always looking for what is shared and what is left over. Now, if I'm going to simplify this expression now, I end up with 36 from dealing with the 6 and the 6 there, x squared y cubed. Now, like I told you, I don't expect you guys to do this when you have monomials. I just wanted you to see why it works. Well, 36 is obviously the LCM of 12 and 18. But when we're looking for the greatest multiple, if you take a look, the greatest common multiple has to have every variable in it when it's monomials. And this 2 happens to be the highest exponent for my x's. Same thing, this 3 was the highest exponent for the y's. So your least common multiple with monomials should include all the variables, and you always use the highest exponent. All right, I'm gonna backtrack a little. Look at number 2, the least common multiple of x and y. Well, they don't have anything in common. So there's nothing shared, so both of them would be considered left over, so your least common multiple is simply xy. All right, and then last but not least, if you're still watching the video. Okay, so when I take a look at example number 4 here, in example number 4, I now have 2 polynomials, but they're not monomials. But kind of like I've done in the previous ones, the first thing that I want to do is I want to make sure that I factor each of these completely. So my 3x minus 6 factors to 3 times x minus 2. And then my x squared minus 4 factors to x plus 2 times x minus 2. But my process of looking for what is shared amongst these 2 polynomials and what's left over remains the same. So when I go to look for my least common multiple, I start with, well, what factor do these have in common? Well, they have the x minus 2 in common. So I write it 1 time. But now I have to look and see, okay, well, if I've already used those, well, then these 2 factors are considered to be my leftovers. And so I write each of those 1 time. Now, I hate the way this looks. I would never write a monomial in the middle. So the way that I would express this would be 3 times x minus 2 times x plus 2. And if you guys are looking to find the least common multiple, multiplying those out is not going to give you guys anything helpful. So what we're going to do next is we're going to look at actually adding and subtracting these rational expressions. And some of these problems or examples will come up in denominators. And we'll kind of look and see, well, what do we do next now that we know how to find them?